Hi everyone, let's continue the discussion. So this question is based on the parallel plate capacitor. So according to question, there is a parallel plate capacitor, and this parallel plate capacitor having plates which is separated by a distance d, and the area of each plate is A, and the electric field between the plate is given to be E. And we are supposed to calculate the amount of energy stored in the capacitor. Well, amount of energy stored in the capacitor is given by C half of CV square, but the options are given in terms of electric field, area and D. We know that we can transform C and V in form of A, D and E. So what is the value of the C in terms of epsilon naught A and D? This is the value. This is the value of the parallel plate capacitor. Again, the electric potential is electric field multiplied by D, assuming that the electric field to be uniform, which is indeed true. So epsilon naught A D multiplied by ED whole square. So when I solve it, I get EA E square multiplied by D. Option 3 is the correct one. Next question. Here in this question, a circuit is given which consists of capacitors, and we are supposed to calculate the equivalent capacitance. So equivalent capacitance has to be calculated between these 2 points, this point and this point. Let's say this 2 point be AB. When we calculate equivalent capacitance, the rationale behind the calculation of equivalent capacitance is that we apply some potential between these 2 points. The points about which we have to calculate the equivalent capacitance. I can see that both the ends of this capacitor are connected to B, which means the voltage across this capacitor will be 0 at any point instant, which means the amount of charge stored in the capacitor will be 0. So this capacitor is not working. So while doing calculation, I can remove this capacitor. So it means my effective circuit will be the following. It consists of 2 capacitors connected parallelly. So in parallel connection, 2 capacitors are connected. Therefore, the equivalent capacitance will be given by sum of them, C1 plus C2. So in this case, it will be C plus C equal to 2C, option 2. Let's move on. Here in this question, 2 statements are given based on the semiconductor chapter. Let's read out the question. Statement A says that Zener diode is connected in reverse bias when it is used as a voltage regulator. Yes, Zener diode is used as a voltage regulator and it works in reverse bias mode. This statement is correct. Second statement says that the potential barrier of PN junction lies between 0.1 and 0.3. Incorrect. Potential barrier is more than that, 0.7 for silicon. Therefore, this statement is incorrect. So option 3 is the correct option. Let's move on. Here in this question, it is given that a particle is released from a height s from the surface of Earth. At a certain height, its kinetic energy is 3 times the potential energy. This is given. The height from the surface of Earth and the speed of the particle at that instance are respectively. Let's try to understand this particular question with a diagram. The situation is like this. There was a particle initially at a height s. Then it is released. Released means the velocity at the highest point was equal to 0. Let's say that point to be A. When it was moving down, then at a certain instant, let's say that instant velocity is v. At that instant, according to the question, the kinetic energy of the particle becomes equal to the 3 times the potential energy of the particle. Again, I am repeating. At this particular instant, the kinetic energy of the particle becomes equal to 3 times the potential energy of the particle. That at the point B is, let's say, located at a height as h from the surface of Earth. And thereby we are supposed to calculate this height as well as the speed of the particle at point B. So what we will do, First of all, from this relation which is already given in the question, I can write that kinetic energy half of mv square equal to 3 times the potential energy at that instant. So from here I can see that this v square is equal to 6 gh, or simply v equal to square root of 6 gh. Now I have to know the value of h to calculate this thing further. I keep this for a moment aside and let us focus on the second part of the calculation. I will apply the equation, the conservation of energy. Let's say what is the total energy at point A. Since the velocity was 0, the total energy at A was the potential energy, which is given by mg multiplied by height. Again, the total energy at instant B is given by kinetic energy plus the potential energy at that point. I equate them because according to the conservation of total energy, the total mechanical energy will remain constant when the forces are conservative, which is true in this case. So mgs equal to half of mv square kinetic energy plus mgh. Let me do the calculation further. I will just put the value of this half of mv square to be 3 times mgh according to the question. Then mgs equal to 4 times mgh, thereby h becomes equal to s by 4. So h is s by 4. That's the value we got it. I put the value here in the v that we have already calculated, 6g s by 4. So it will give me square root of 3 by 2 gs. So option number 4 is the correct one. Let's move on. So here in this question, two quantities are given. One is energy, one is the universal gravitational constant, and we are supposed to calculate the value of the dimension. So energy divided by g. So directly we can put the value of the dimension. If you can remember the dimension of energy, it is ml square t minus 2. Suppose you cannot remember the dimension of g, you can take any formula involving g. Let me take it F equal to g m1 m2 divided by r square. From here g will be equal to f r square divided by m1 multiplied by m2. So dimension of f is f ml t minus 2, distance is l square, m and m, it will be m square, it will be equal to m minus 1 l cube t minus 2. Now let me put it here, m minus 1 l cube t minus 2. So this will give me m square l minus 1 t0. So this is the answer, option A. Let's proceed. Okay, so this question is like the previous question that we solved, which was based on the current electricity. So some quantities are given and we are supposed to identify the formulas. These formulas are very basic, which are direct formulas of the kinetic theory of gas chapter, where we already know the root mean square speed of the molecule is equal to this one. So this is a q, direct formula is given. Pressure exerted by the ideal gas is 1 by 3 times RMS velocity square multiplied by this quantity. So this is V equal to P. After that, average kinetic energy of molecule and total energy of 1 mole of diatomic gas. Diatomic gas means, it strikes me, diatomic gas means degrees of freedom should be 5, and this is the 5 term. So D equal to R and C is S. Let me check which option is correct. I think option C is correct one. So this is the option 3 is correct. Let's move on. This question belongs to SHM, and in this question it is mentioned that a body is executing simple harmonic motion with frequency n. The question is, what is the frequency of the potential energy? Very basic question. So what is the displacement? Displacement may be written like this in simple term, may be written like this. Let's say this is the frequency. or you can write down the frequency in terms of angular frequency. And we know that the potential energy is given by half of kx square, which is proportional to sine square and so on. And if I plot the graph of x, it will be a simple sine graph, and one cycle consists from here to here. At the same time, the potential energy graph looks like this. The one cycle of potential energy completes in a time which is half of that of the displacement cycle. Thereby, the frequency of the potential energy is 2 times the frequency of the displacement. So answer is 2n. Let's move on. This question tells that a cup of coffee cools from 90 to 80 in T minutes when the room temperature is 20 centigrade. This is the first part of the question. Second part of the question is the time taken by this similar cup of coffee to cool from 80 to 60 when the room temperature is 20 is equal to what? So there are two cases. First of all, this question belongs to Newton's law of cooling. So change of temperature with respect to time, rate of cooling, equal to this constant multiplied by the average temperature minus the room temperature, or let's say T naught. So for the first case, I will write it like this. For the first case, the coffee cools from 90 to 80. So what is the difference? 90 minus 80 is 10 by T. Okay. What is average temperature? Average means this T average will be, for the first case, 90 plus 80 divided by 2. So what will be this? I think this will be 85. So this is 85, and the room temperature is 20. So this is 10 by T equal to K multiplied by 65. Keep it as equation 1. Let's move to the second part of the question. It says that what is the time taken by the similar cup of coffee when it cools from 60 to 80. So here it cools from 80 to 60. So when it cools from 80 to 60, then change of temperature is 20. So when I write down the Newton's law of cooling, it becomes equal to 20 divided by time. That time I have to find. Let's say that time is T1. Then what is the average temperature? In this case, average temperature is 80 plus 60 by 2. It is equal to 70. So 70, and room temperature is 20. So 20 by T equal to K, this is 50. Now just let's divide equation 1 by 2. So this will be equal to 10 by T multiplied by T1 by 20 equal to K 65 divided by K 50. So this is equal to this will be 2. So T1 will be equal to, this 2 will go this way. So 65 by 50 multiplied by 2T. So this will be equal to 13 by, this will be 13 by 10 into 2T. So this will be 13 by 5T. So answer is option 2. Let's move on. This question tells that the capacitance of a capacitor is C, and it is connected to a voltage source, AC voltage source, which is the conventional source V0 sine omega t. What is the displacement current between the plate of the capacitor? Well, when we consider a capacitor, then this displacement current and the conduction current are same. Displacement current and the conduction current are same, and this voltage is directly connected to the capacitance. So it's a very conventional circuit. So in this case, we know current will be equal to V0 divided by this XC multiplied by sine of, since it is pure capacitive circuit, therefore the current will lead the voltage by 90 degree. So in this case, what will be the capacitive reactance? Capacitive reactance will be equal to omega c. So this will be omega c sine omega plus 90, sine omega t plus 90. What is this? Sine omega t plus 90 is cos of omega t, and thereby v naught omega c cos of omega t. That's the correct one. So option 1 is the correct one. Let's move on. Here in this question, it is mentioned that half-life of a radioactive nuclei is 100 hours. So let me write down half-life is equal to 100. The question is, what is the fraction of original activity that will remain after 150 hour? Let's say the initial number of particle, initial activity is, let's say this is equal to this one. This, and let's say this is the initial activity, and after some time, after 150 hours, the activity is this one. So the fraction of activity is given by this one. So this is equal to half of n. What is this n? This n is the number of half-life. Number of half-life means total time by one half-life. So this is 150 divided by 100. This is 1.5. So this becomes equal to 2 by n. So this is 2, 1.5. What is 1.5? 1.5 is 3 by 2. Now I check the options. I have to convert the calculation in terms of square root perhaps. So I will write it like this: 2 into 2 power half. So this is equal to 2 square root of 2. So answer is option 2. I hope this is clear. If it's so, let's move on to the next question. Okay, in this question, there's one LCR circuit where L, C and R all are here, and some values are given, and we have to calculate something. Let's read out the question, and together we will note down the values as well if it is given. An inductor of inductance L, a capacitor C and the resistor R are connected in a series to an AC source of potential V. The potential across L, C and R are 40, 10 and 40 given. So VL equal to 40, VC equal to 10 and VR equal to 40. The amplitude of the current through the LCR circuit is equal to 10 square root of 2. So this is equal to the peak current. Amplitude of the current means the peak current is this one. Amplitude of the current, peak current. And we are supposed to calculate the impedance. Impedance means the magnitude of the impedance. Well, what strikes our mind is that VRMS equal to IRMS multiplied by amplitude, or V naught equal to I naught multiplied by amplitude. So in this case, amplitude will be equal to VRMS by IRMS. Let's calculate the VRMS first. Since all the voltages are given, I can calculate VRMS like this: VR square plus VL minus VC whole square. VR is 40 and VL minus VC is 40 minus 10 is equal to 30. So this will be equal to 50 square, which is equal to 50. So VRMS is 50. What is IRMS? IRMS is I naught by square root of 2. So 50, 10 square root of 2 by 10 the square root of 2. So this will be equal to 50 by 10. So answer will be equal to simply 5 ohm. I'm sorry. This is, I think I made a mistake. Just wait. Yeah, it's correct, 5 ohm. So next one is this one. Here a thick current carrying cable of radius R and carrying current I is given. It's like this. Suppose this is the thick cable which carries current I, okay, and the radius is R. Now we all know that whenever a conductor carries some current, then it can cause to produce the magnetic field. Now magnetic field produced by a straight wire is given by B equal to I by 2 pi R outside, and inside it is given by B equal to mu naught I R 2 pi R square. Thereby, in case of inside, it is directly proportional, and this graph is directly given in NCERT. We do it often. So this is the answer. Next, here in this question, an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m is the mass of the photoelectron emitted from the surface has de Broglie wavelength lambda, then which of the following relation is true? Let's understand the description of the question a bit closer. According to this question, let's say this is the photosensitive metal. So the photons with energy, let's say hc by lambda. I'm writing it in terms of lambda because the question is mentioning lambda. It will strike and the electrons will come out with certain amount of kinetic energy. Now when electron comes out, it must have some momentum, therefore it will have some de Broglie wavelength also. Let's say the de Broglie wavelength of the electron is lambda. So I have to relate or find a relationship between this lambda and this lambda. So how can I do it? Look at the first part of the statement. It says that electromagnetic radiation of wavelength lambda incident on a photo surface of negligible wavelength. So first what I will do is I will write down the Einstein's equation. Okay, Einstein's equation. What does it say? It says that the incident energy is equal to kinetic energy plus work function. Since it is given that the kinetic work function is negligible, therefore I can neglect it and this becomes equal to the kinetic energy. This is the first part of the question. What is the de Broglie wavelength? De Broglie wavelength is h by p, or in terms of energy or kinetic energy, it is given by h by square root of 2me. So this is nothing but kinetic energy is the energy in this case. What I will do is that I will just square both sides. Let's say square h square and 2me. Now I will put the value of this e, d square equal to h square 2m multiplied by e is hc divided by lambda. So this is equal to h square lambda, this is 2mhc. Little bit of more simplification, this will be equal to lambda d square equal to h lambda 2mc. Let me continue this here, which will give us lambda to be equal to 2mc divided by h multiplied by lambda d square. So I think the correct option will be this one, lambda equal to hc by this one, option 3. Now let's move on. This question tells that the escape velocity from the Earth's surface is v. The escape velocity from the surface of another planet of a radius 4 times that of the Earth will be equal to what? Keeping that the planet has the same density as Earth. First of all, the escape velocity is equal to square root of 2gm divided by r. Now when I want to convert this into density, why? Because this question is mentioning density. So mass is equal to volume multiplied by density. For spherical planet, density is given by, sorry, volume is given by 4 by 3 pi r cube, and this is the density. So I get that in terms of density, the expression for escape velocity will be 8 by 3 pi rho g multiplied by r square, or simply this is equal to square root of 8 by 3 pi rho g r. What does it tell? It tells that escape velocity is proportional to r. Now you see, if the radius is increasing, then escape velocity will increase when the density is same. The question says that escape velocity of Earth is v. What is the escape velocity of the other planet having a radius 4 times the Earth but the same mass density? Both the planet have same mass density, which means v proportional to r. If the radius becomes 4 times r, then escape velocity will become 4 times the escape velocity of Earth. So answer is option 4. Let's move on to the next question. This question is based on the dimension. It is said that force, acceleration and time are chosen as the fundamental quantities. What is the dimension of energy? Well, we can do it by putting the original dimension and solving. We won't do this because it will be a lengthy task. We can use, in order to do it in more short form, we can use unit method. We can write down the unit and little bit of simplify. But you see, we are supposed to calculate energy. Dimensionally, energy is equal to work done. Okay, energy indeed interpreted as work done. So energy means what? This is force multiplied by displacement. Okay, dimensionally. So force is already there. We have to get acceleration and time. Now displacement divided by time is velocity, and change of velocity by time is what? Acceleration. So 2 times are written here, so I will write time square. So this will be f, this displacement, this is meter per second square, it will be equal to acceleration, and this time will be t square. And thereby what we will get is that the option, I think FT2, option 2 is correct one. Okay, let's move to the next question. This question says that there are 2 circular loops. Let's say this is loop 1 and this is loop 2, and the radius of the loop are, let's say this is R2 and this is R1. This is R1. Okay, now the question is, what is the mutual inductance between them? Well, what is mutual inductance and what formula will give us mutual inductance? We know that the flux on second, the amount of electric flux on the second coil should be equal to mutual inductance multiplied by the current in the first coil. Okay, let's say current in the first coil to be I1. Okay, what is the magnetic flux on the second coil? That we will calculate. Magnetic flux on the second coil is equal to the magnetic field multiplied by the area. Now magnetic field caused in the second coil will be due to coil 1. So due to coil 1, magnetic field at the center will be this one, 2 pi, this is R1, and the area of the second coil is pi R2 square. Now if I compare this with this relation, then what I get is that mu naught pi R2 square divided by 2R1 multiplied by I1, which will give us that m is equal to mu naught pi divided by R1 R2 square. So this m is basically proportional to R2 square by 1. This m is basically proportional to R2 square by 1. So this is option 4, which is correct.